Hello everybody, in this video I will talk about graph data structure. Graph is a non-linear data structure. It consists of vertices and edges. Vertices can be termed as nodes and edges can be also termed as arcs. Vertices are connected by edges or arc. Okay, the connection between vertices or nodes is called arc or edge. Now let's see a simple graph. Let's suppose we are having a four different nodes and there is a connection between these nodes like this. Okay, so let's suppose this is A, this node is B, this node or vertex, this is C, this is D, and this is the connection between A and B. We can find lots of applications of graph in our real life. Graph can be used to represent connection between the cities. It can be used to show the connection between computers within the network. Okay, the wire which is used to connect the computers are the edges or arc, and the computers are vertices or nodes of the graph. In computer we can use different methods to represent graph. Okay, so first we can use adjacency matrix, then we can use adjacency list. Okay, now let's suppose there is one more connection. Now in order to represent this graph using adjacency matrix, what we do is we will make a table like this. There is a connection between A and B, so we will be writing 1. Okay, A and B, B and A, we can write 1. Okay, it is undirected graph. Undirected graph. So there is the connection, another connection B to C. So B to C. Here we will be writing 1, C to B 1. There is no arc from a node to itself, so we will be writing 0. There is no arc from A to A, B to B, C to C, and so on. And so we are writing 0 here. Now there is another is C to D, C to D. We will be writing 1 here, we will be writing 1 here. Similarly, there is the connection between A to D, and okay, D to A. Similarly, there is the connection between D to B. Okay, fine. D to B, B to D. So in this way, using this table, we can represent this graph. This is the adjacency matrix. Now, if we talk about the adjacency list, what we do is we will be creating the link. This is the node representing A, this is B, and this is C, this is D. Actually we are having 4 nodes. So A is connected with B, A is also connected to C, A is also connected to D. Then there is nothing. Now B is connected with A, B is connected with C, B is connected with D, C is connected with A, C is connected with B, C is also connected with D. So using this list, we can represent the graph also. Okay, here what we are doing is we are creating the chain of the nodes, and for particular node, what other nodes are connected are chained like in a linked list. Okay, so in this way we can represent the graph in computer. Okay, now let's see how we can implement this. Okay, adjacency matrix. I will be writing a simple code for this. Okay, let's suppose we have a class graph. Okay, class graph, then inside graph we will be declaring 2-dimensional array. Suppose it is G Okay, we'll be writing a constructor public graph. Okay, we will be initializing z. Let's suppose there is the default graph with 4 nodes only. Okay, simple. Then we'll be using another constructor graph, and we'll be specifying number of vertices. Okay, rows and columns. Simple. Okay, here we'll be writing z is equal to new int r and c. Now what we can do, we are supposed to define a function to add the edges. Okay, void add etc edge. Now we have to specify the vertices. Okay, start int destination. Okay, now we will be doing z yes d is equal to 1 and z d yes is equal to 1. Simple. Now we'll be having another more function here, public void, to return this graph, get graph. This will return this graph g. Okay, simple. This is a very simple definition. Okay, here I have defined a class graph. Here I am declaring 2-dimensional integer array z. This is the constructor without parameter, and in this constructor I am initializing z with 4 by 4. Okay, 2 dimension having 4 rows and 4 columns. There is another constructor here. I have specified number of rows and columns. User have to supply this r and c, and this is the method which will be used to make a connection between vertices. So when this method is called, we have to specify start and end. Suppose there is a connection between a and b, then we will specify 0 and 1. The a is represented by 0, b is represented by 1. In the previous graph, what we can do here is that assume that this is 0, this is 1, this is 2, this is 3. Okay, so if we can specify like this, then we can say 0 and 1, there is a connection between 0 1 by assigning this 0 1 is equal to 1, 1 0 is equal to 1. So in this way we can create a simple graph. Okay, now let's write a driver program for this, named graph demo. Class graph demo, then within the main function public static void main string a. Okay, now here we will be creating object of this graph z is equal to new graph. Here we will be using constructor without any argument. We will be creating a 2-dimensional array of 4 by 4 size. Okay, then what we have to do, we have to call this add edge. Okay, z dot add edz. Now I will be making another graph. Suppose we have a simple graph like this. Okay, this is the graph a b c d. Now let's suppose this is 0, this is 1, this is 2, this is 3. Okay, so what we have to do to make the edge between a and b, we will be supplying 0 and 1. Then to make the edge between this a and c, z dot add edge. This is 0, this is 2, 0 comma 2. Then similarly z dot add edge. This is 3 2, 3 comma 2. Then there is one more edge, z dot add edge. Okay, 3 comma 1. Okay, simple. So in this way we can call the add edge method of this graph class, and we have to supply source and destination. We have to specify the vertices for which we have to make the connection. Okay, now how to display this graph, let's see. Okay, let's define another array, suppose z1, and let's assign z1 is equal to z dot, our method here is get graph. Simple. Okay, whatever graph that been created here, whatever two-dimensional matrix created, that will be returned and assigned to this g1. Okay, now we can use the for loop to display this one. For, okay, integer I is equal to 0, I less than 4, we know the signs already, I plus plus curly braces, for I into int j is equal to 0, j less than 4, j plus plus. Now we have to check if z1 I j is equal to 1, then we will be displaying. Okay, system dot out dot print ln z1 I j plus, okay, one space less. Okay, if there is no one, I will be writing else part here. Okay, else system dot out dot print ln, I have to specify 0. It's simple. Okay, 0, no problem. Okay, this is the else part, this is the one, this is the 1, 1, 2, okay, fine, main and this. Okay, so in this way we can write the driver program to execute this graph. Okay, so this is a very simple logic to represent the graph using two-dimensional array and using this object in which this two-dimensional array is defined. Okay, thank you very much for watching. Thank you very much.